Coming up on Energy Switch, we wrap up our discussion on the urgency of climate with policy suggestions.
There is a real cost to climate change. There's a real cost to doing climate policy. For every dollar we spend, we avoid about 17 cents of climate damage. That's a terrible investment.
What's the upper limit damage of switching to renewable energy? Maybe your energy prices go up a little bit, but there's nothing like the civilization-crushing impacts that could happen with 3 degrees of warming.
Next on Energy Switch, the urgency of climate change, Part 2.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world.
I'm Scott Tinker, and I'm an energy scientist. I work in the field, lead research, speak around the world, write articles, and make films about energy. This show brings together leading experts on vital topics in energy and climate. They may have different perspectives, but my goal is to learn and illuminate and bring diverging views together towards solutions. Welcome to the Energy Switch. In Part 1, our guests disagreed on the media's reporting of climate change, the political power of fossil fuels versus wind and solar, and whether continued adaptation will be successful. To conclude, they'll each lay out policy ideas for responding to climate change, reflecting their views on its urgency, including a carbon tax, energy innovation, geoengineering, decarbonizing electricity, and reducing fossil fuel investment. With me again are Bjorn Lomborg. He's president of the Copenhagen Consensus, a think tank, a political scientist and researcher, and the popular author of 4 books on climate and global society. Andy Dessler is a climate scientist and professor of atmospheric sciences at Texas A&M University, and author of 3 books on climate change. On this episode of Energy Switch, Part 2 of The Urgency of Climate Change. Well, welcome back. We're going to kind of get into some of your main issues, and you've got 5 big things you talk about.
So the first point, and you know, if you ask any economist, they would say you need to have the correct price signal. So you should basically have a carbon tax. The newest sort of estimate seems to indicate that perhaps it should be in the order of $20, $30 per ton of CO2. Yeah. The Biden administration is inching upwards of 100, maybe even $180. But what is important to recognize is almost nobody does this. Most rich countries have some carbon taxes, but very inconsistently placed, and poor countries, virtually nothing. So we would definitely agree that you need to do more. We should also recognize that any sort of realistic carbon tax, because this is a politically very, very infected area, is not going to be the main part.
Thoughts on carbon tax?
Yeah, I think we agree on this. I think the mainstream economic view is closer to $200 a ton, if you look at some review articles that have come out. But, we just need something that once you put something in there, what you're going to find out is it's much easier to switch away from emitting carbon than people say. The problem, of course, is you run into the political problems. There's this idea that tax is bad. And certainly taxes on some things are bad. But if you tax something you want to get rid of, that's a good thing. So you tax carbon because you want to get rid of it. And it's just really an issue about battling the entrenched interests that have no interest in phasing out fossil fuels.
While this is a theoretically correct argument, I think we both agree this should be happening. By far, and that's my second point, by far the best way to solve climate change is by making green energy cheaper. That happens through innovation. If we can innovate green energy to be cheaper than fossil fuels,
and green means low emissions.
Yes.
Right.
If you think about in the 1950s, Los Angeles was a terribly, terribly polluted place, mostly because of cars. And so we invented the catalytic converter. It cost a little bit of money, and then basically you put it on the tailpipe, and then there's, compared to previously, virtually no emissions. So the simple point here is to say, the way that we've solved most problems is not by making really, really hard decisions that requires a lot of push through the political system to get it done, but coming up with an innovation that basically makes it costless.
Right.
It's about making sure that everyone will eventually switch. That's China, India, and Africa. And we're only going to convince them if we come up with technology that's cheaper.
We change when something better comes along.
Yes.
Finding the better fuels, if you will, better energy sources it's not simple. Let's talk about adaptation, or the simple one here.
Yes. Fortunately, it's very often very, very simple, very cheap. There's often large-scale private benefits to do adaptation. So, for instance, if it's hotter in your neighborhood, you don't have to keep your heat on for as long, but you do need air conditioning, and that means possibly that you'll have to buy an air conditioner. We also need to build more water infrastructure. We know how to do that. Again, remember, we have this idea that as sea levels have risen over the last 100 years or so, mostly because temperatures have increased, we have actually adapted to that. There's actually more dry land in the world today than there used to be. Why? Because it's profitable and it's often very cost effective. And so we should keep doing that. Of course, there's still a lot of other considerations about the fact of what happens to poor people, because again,
Right.
if you're really poor, you can't afford to adapt.
Right. Thoughts on adaptation?
Again, this idea that we can easily adapt, I think, is just absolutely, it's just fairy dust. You see us not adapting. So, Dr. Lomborg, we talked about air conditioners previously. He said, people will adapt. They will buy air conditioners. Okay, so let's imagine they buy air conditioners. They're quite a bit poorer now because they're spending money they could have spent on tuition or starting a business. But now they've got to build a seawall. Where's that money going to come from? Now we have to build stormwater infrastructure. Okay, well, how much is that going to cost? Now, clearly, if that were the only option, we would have to do that. But again, you always have to say there's another adaptation, and that's the adaptation to a world without fossil fuels. And let's avoid the political issues and just look at the economics. And that's going to turn out to be a world that's actually a lot cheaper.
Why do you think that?
Okay, so fantastic question. So let's talk about how the Texas grid operates. Your number one energy source is wind and solar, because those are basically free. So anytime they're available, you're using those.
The sun and the wind are free.
The sun and the wind,
But
yes.
the turbines and panels aren't.
No. I mean,
Yeah.
the marginal cost is zero. Once you build them, anytime the sun's shining or the wind's blowing, you're cranking that power.
Right.
Now, as everybody knows, I've been told many times on Twitter, the sun doesn't shine all the time, the wind doesn't blow all the time. So you need to have dispatchable power that can make up for that. And in Texas, that's almost always natural gas. And natural gas is expensive. Its marginal cost is not zero. So every unit of natural gas you buy, you have to pay for. And you might say, wow, that's expensive, because you have to have natural gas plants and you have to have wind and solar plants. And it turns out it's not expensive because building natural gas plants is cheap. When you buy electricity from natural gas, you're mainly paying for the gas. And that allows, for example, these peaker plants. These peaker plants run 10% of the time. It's like 1,000 hours, 1,200 hours a year. And they still make money because they're running at times you really need the power, so they get paid for it. It's not the case that you have to pay for 2 energy systems, so it's doubling your price.
Your thoughts on that?
The short version is, Andy is absolutely right, that you don't need to pay twice. But it's still true that you need to have almost 100% gas turbines, if that's going to be your backup, and actually much more than 100% solar and wind, because they don't run all the time. And those are reasonably expensive. But the real point here is, and this is what worries me a lot, is that people will argue, oh, we can build this beautiful system and it's going to cost almost nothing. If you look at all the nations have actually tried to do it, so Britain, Germany, there is enormous costs. And we're nowhere near these costs. Now, obviously, one of the points, for instance, in Germany is that they incomprehensibly decided to say, we're also going to get rid of all the nuclear power plants. That's just stupid beyond belief, and I'm pretty sure that you and I would perfectly agree on that, right?
Yeah.
Yes.
Yeah.
So the problem is, frustratingly, politicians will do incredibly stupid things. It seems to me that if we're really going to change the whole world economy on this, maybe we should get somewhere specific to actually work out, can this be done? And the point, I suspect, is that we're going to find that it's much harder and much more costly than what we think.
It is being done in a few places.
Can I just, I'm very short.
Sure.
This will be very short.
Sure.
I think that Dr. Lomborg really applies a double standard to his adaptation to climate impacts and energy. He's very skeptical that we can do stuff with energy. I think that if you want to apply skepticism to energy, and that's fine, you have to apply skepticism to adaptation. Maybe the two of us need to combine our skepticism a little bit, because I'm very skeptical about adaptation. You're very skeptical about energy. I think that it's not nearly as clear-cut as you seem to think.
Geoengineering, what is it?
So geoengineering is essentially the idea of putting, if you will, sunshades on the world. The big problem is that climate change is essentially an imbalance between the influx from the sun and then the outpouring of energy. And because CO2 essentially acts as an insulator, if you will, it keeps a little more of the heat in there. If we could avoid a little bit of the sun coming in, we could essentially outweigh the whole problem of climate change. We looked at an idea of creating whiter clouds in the Pacific. Whiter clouds will reflect sunlight back and will essentially reduce the temperature on the planet. Do we know this works? We kind of do. But do we know all the bad side effects? No, we don't at all.
So you can ramp it up quickly and you could ramp it down quickly?
If you start doing it, you need to keep on doing it.
Yeah.
So what we're saying is we shouldn't start doing this because this is dangerous in a lot of different ways and we want to know what works. But we should be looking into it because you could avoid all of the temperature rise in the 21st century for about $10 billion. That's 1,000 times or more cheaper than anything else we're talking about, probably much, much more than that.
Yeah, interesting. Thoughts on geoengineering?
I think he said it perfectly. We should be researching it, but I don't know anybody that says that should be how we deal with climate change, and I think that's appropriate.
Interesting. Prosperity, you mentioned it.
Yes. It's very easy to get involved in the climate conversation and talk all about CO2 and temperature and climate models and all these things. But the end of the outcome, it should be about, is life better? Obviously, if you're better off, if you're not in poverty, you're much better able to adapt, not just with climate, but with everything else, like bad education and infectious diseases and all these other things. And we often forget it because we get so wound up in just talking about CO2.
Prosperity as a driver.
Yeah, I mean, the reason we care about climate change, the reason we care about anything is, human prosperity and the value of the natural environment. I don't know anybody who doesn't agree with that. There probably is somebody.
There probably
are somebody out
there.
there.
Get rid of the humans.
That's right.
Life would be better for who?
But I think that Dr. Lomborg is trying to set up this choice between we can pursue prosperity or we can deal with climate change. I think that's a false choice. In my mind, prioritizing prosperity is a world that's carbon-free. Now, what's the risk? We know what the floor is because the economic models that estimate the costs of climate impacts, they've done a heroic job of estimating certain things, but as they learn more, it's like, oh, we didn't include that, we didn't include that. The cost keeps going up. I talked to a lot of economists, and they say, we really don't know what the upper limit damage is. Now, what's the upper limit damage of switching to renewable energy? Maybe your energy prices go up a little bit, but there's nothing like the civilization-crushing impacts that could happen with 3 degrees of warming.
3 degrees C.
3 degrees Celsius, about 5 degrees Fahrenheit.
Yeah.
So Andy's absolutely right. We need to have a conversation about how damaging do we think it could be. So fundamentally, there is a real cost to climate change. There's a real cost to doing climate policy. Just to give you one example, going net zero in the 21st century, the net damage cost is on average per year about 1%. Obviously, it escalates, so it gets worse towards the end of the century. 1% of GDP. The cost of doing this is about 8% of GDP. Or to put it differently, for every dollar we spend, we avoid about 17 cents of climate damage. That's a terrible investment.
Yeah, so can I say something about this? Because I'm not an economist.
Right.
Dr. Lomborg's not an economist. We talk to economists, but nonetheless, let's go over a little bit about economic models and what goes in them. And let's compare them to physical climate models. So if I might want to make a prediction of the physical climate, I know that the climate has to obey the fundamental laws of physics. And that's why climate models have done such a good job of reproducing the climate over the last 30 years. Economics, there are no theories. There is no data for 3 degrees or 2 degrees. So these models basically just make up what we call damage functions. And what they say is the damage goes as the temperature squared. But we don't know that. Maybe it goes as temperature cubed, or temperature to the 5th, or temperature to the 10th, meaning for every degree, you get much more damage. We simply don't know. And that's why Nordhaus says we're rolling the dice.
I want to make sure I understand the language. You've said many times we've got to get rid of fossil fuels, but also it's the emissions are the challenge, or decarbonizing.
Right.
What's your thoughts there, decarbonizing the energy sector, and then you can kind of respond to that. So.
Sure. I mean, carbon tax, we talked about carbon tax. That's certainly one way to do it. You also need targeted investments. And you need to, again, I've talked a lot about the power of organizations to tilt the market in their favor, even when the economics don't support it. In this case, fossil fuels. I think you've got to somehow figure out how to stop them from doing that.
I mean, we agree on the goal because climate change is a problem, so decarbonizing the energy system is a good thing. The real question is how quickly can we do it? And I think the real point here is to say this is much, much more hard than I think anyone really realizes. This is a small part of the solution, and this is only for electricity. Getting the rest of it, so the 80% that is not electricity, on electricity is going to be fantastically hard.
I agree that decarbonization is going to be a challenge. It might be the hardest problem humanity's ever had to face, but the alternative is also the hardest problem we've ever had to face, which is how do we deal with what could be, I mean, again, 3 degrees Celsius, 5 degrees Fahrenheit, it's a geologically enormous amount of warming. The impacts could be incredibly difficult to deal with, and trying to adapt to that could also be incredibly hard. And I think the economists that represent the bulk of the economic thinking, maybe not Richard Toll, agree that the upside is essentially unlimited, that we just don't know how bad it's going to be.
Yeah. Talk about...
Sorry, I just have, because this is a great example of what we're talking about. You're basically saying decarbonization could be the hardest thing humanity has ever done, but it's going to be fantastically cheap. Come on.
Decarbonization is going to be hard because of the political battles. There's going to be all of this opposition to, we don't want you to build a power line or siting wind turbines or things like that. That's what's going to be hard about it, not the technology.
No. We agree that the technology is not hard. It's the cost that is hard. And you're somehow saying, oh, it's incredibly cheap and it's actually going to be beneficial, but it's politically going to be impossible to do.
That is exactly what I'm saying.
Okay, that's probably true in the US. We also know for a fact that the US is much less well adapted to pretty much all weather effects than pretty much anywhere else in the world. That may be a particular outcome of a dysfunctional political system, but it's just not true for 90, 95% of humanity. And so I think this is a very parochial view that's not relevant for how most of the world is actually going to deal with climate change. We have adapted enormously well, but it is going to be fantastically costly to go down the route that you're talking about.
Let's come back to some of your important points here, Andy. Reducing fossil fuel investment, that's another thing you're talking about.
So you don't want to lock in, you don't want to approve infrastructure that locks you in to emissions for the next century. Mm-hmm. You don't want to build a pipeline that you're going to have to run for 100 years. They're building infrastructure because they can make a lot of money doing it. There may be a case where you really do need something, you should go ahead and build it. But otherwise, try not to build new infrastructure.
Okay, thoughts?
If we're still going to use a lot of fossil fuels, making it much more expensive is actually really terrible for two reasons. Partly because it makes people have to pay a lot more for all the energy they still have to pay for. And also, as we're seeing less and less growth, we know empirically that this is one of the things that leads to polarization. And so chances are you're just going to get all the green politicians booted out of office. And that could potentially be a much worse outcome in the long run for societies.
Which kind of brings you to an important point of yours, I think, is international and national coordination.
Right. So one of the arguments that you'll often hear people say is, what about China? The U.S. can do all they want, and it's not going to affect the climate by itself. And that's actually correct. We really need concerted, coordinated international action. And, one way, which I think does not work, is kind of the old Kyoto Protocol approach of trying to get everybody into a room and get everybody to agree. So a better suggestion, in my opinion, is to start with countries that are willing to get together, and then you form essentially trade blocs, and you give incentives for countries that are not in to join. And as part of that, we have to give them technical assistance. That's part of the heavy lift.
I'm a little less sanguine than you are, but I totally agree that the way that we've been trying to do climate policy for the last 30 years is essentially having a lot of nations get together and make solemn promises that they then break. There's a concern in which if you make free trade contingent on whether you're also doing well on climate, you may very well end up throwing out a big growth engine out the window in order to try to fix a smaller problem. And so we may very well end up losing out on the wider benefit.
So how do we end up paying for all these approaches? You've outlined quite a few things, and so have you. How do we pay for all that?
I will make this statement that I think a lot of people would agree with, that we can basically solve this problem at no cost. And let me tell you, what does history tell us about this? So climate change is not the first environmental problem we've had. We had ozone depletion, for example. And before ozone depletion, before we phased out the chemicals that were destroying the ozone layer, you heard exactly the same arguments about how expensive it's going to be. And it turns out it was so cheap when we did it that nobody actually noticed. And this has been repeated time and time again because people are so clever. Once it becomes clear to the private industry that this is going to happen, you unleash the power of innovation. And you look at the price of solar the last 10 years, nobody predicted it was going to drop 90%. And that's happening with batteries right now. And so whatever you think it's going to cost to reach net zero, reach any target you pick, it's going to cost less than that. I mean, that's what history tells us.
We're absolutely a very inventive species. The solution to the ozone layer was a very different one. We basically found an alternative that was almost as cheap. But what we also know is that we have made lots of other bumbling environmental investments. So obviously, the Superfund in the U.S., where you decided there were big places that were incredibly polluted, that turned out to be an incredible boondoggle with most biofuels, which is a huge issue, which a lot of environmentalists have pushed in very hard, and I understand that we probably agree. That was also a terrible decision. Now, there's a possibility that it turns out that we're going to be incredibly smart on all these things, and it just works out. That would be a wonderful outcome. But certainly looking from here, it looks like the cost, for instance, of going net zero or anywhere close to that is going to be phenomenal. First of all, because we're totally underestimating how much it's going to cost to get reliability. The second part is that the vast amount of human energy use is not electricity.
I'm going to ask you each to do something. A couple of things that you agree with Andy on in support, and then I'll come back to you and do the same thing.
I think Andy and I agree on a lot more than what this conversation would probably let on. I mean, we agree climate change is real, it's man-made, it is an important problem, it is something we should fix. We agree that carbon tax could be a good way of solving it. Innovation is a great idea. We should also be focusing on adaptation. We agree that we should recognize that geoengineering is something we should be researching. We agree that general prosperity is good. We just disagree on the sort of combination of this. And I think, again, we're looking out into the future, and there's no way we can see perfectly what is out there. And I think it's more likely that the truth is somewhere here in between.
Yeah, I mean, I think that, again, we do agree on a lot of things. There are some important things we disagree on. And let me just say that Dr. Lomborg has mentioned a lot of important problems, poverty, for example, and we 100% have to solve those. I'm not so sure that you can separate those. Poverty and climate change, if in a worst case scenario, they're going to be a linked problem. And so I don't think you have to make a decision of these are the problems we're going to solve and we're not going to worry about this. You solve them all. I think the places where we disagree is there a chance that climate change could be really terrible? And I think that once you acknowledge that there's a chance, then you're no longer in cost-benefit space. You're in sort of risk management space, where you have to use a different framework. And I really think that's probably the main place where we would disagree. I think we agree on most other stuff, but it's really that. And we probably disagree on the, maybe where renewables are right now. But I think I'm sort of surprised at all the things we do agree on.
Yeah. That's good to hear. I think it's good for our viewers to hear, too. Thank you. We appreciate you being here. Great thoughts and dialogue we've had. Scott Tinker, Energy Switch. In this episode, my guests agreed on some things, like a greater focus on new energy innovation to try to drive down costs, and more research in geoengineering, which might reduce warming more cheaply than remaking our energy system, though many engineers worry about its potential risks. They agreed on a carbon tax, though some economists do not, but disagreed on its price. They disagreed again on adaptation. Andy says we can't afford to adapt, but can afford to decarbonize. Bjorn countered that countries that have tried found it very expensive, and that was only for electricity, not the other 80% of our energy. Andy wants to reduce new fossil fuel investment. Bjorn worries that will make all energy more expensive for all. In the end, Bjorn considers this a cost-benefit analysis, a measuring of trade-offs, while Andy considers it risk management. Their views of urgency vary accordingly.
Funding for Energy Switch was provided in part by the University of Texas at Austin, leading research in energy and the environment for a better tomorrow. What starts here changes the world.